and we're going to have a black swan event around Gen AI and security. I just already know it's going to happen. So
Yeah,
how do I help? And what areas do I need to protect these models? Because you said you guys are all about data protection. Well, these models are just data. They're really just data,
that's
right?
right. Yeah, it's an interesting question, and maybe I can just take a step back before we talk specifically about Gen AI, because you and I have had this discussion before. We have a good bit of experience at protecting what I call algorithmic AI.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On this episode, Embracing Confidential Gen AI, with returning guest Patrick Conte, VP of Sales at Fortanix. Patrick, welcome to the show.
Thanks, Darren. Good to be here. Good to see you again.
Again, I know it. I always have fun talking to you, and we saw each other just recently at the AWS summit. And you said, "Hey, Darren, I got this crazy idea," and I go, "Oh, wait, don't tell me everything about it. We want to hear about your crazy idea on the show."
Right.
And it's actually very timely right now. And but before we jump in, I know you've already given your background story, but tell everyone what you've been up to. What's been going on with Patrick and Fortanix?
Yeah, lots of things have been going on with Patrick and Fortanix. We've been out in the marketplace, obviously working with customers that are looking for data security solutions, things that are focused around zero trust, some of the different areas about using confidential computing to help protect data at rest, in motion, and in use. And as you know, Darren, because we've been working together for a long time, we're really the only company in the industry that uses confidential computing as a foundation for data security. So we're able to actually deliver across that entire spectrum of the life cycle of data.
How are you finding the whole confidential computing? Because this all fits in the confidential computing. I hate to call it marketing hype because
Yeah.
it's more than that. But how does it fit in that whole realm of confidential computing? Are you seeing people starting to get it now and understand it to the point that you don't have to teach them what it is anymore? That they're like, "Hey, yeah, I do understand that. I want that." Are we
A
starting to
little
see
bit,
that change?
a little bit more. I think so. I think finally the message that you guys have been delivering, we've been delivering, and others, in the marketplace, including some of the cloud providers, have been starting to talk more and more about it. It's starting to have some positive effect. I will say though that a lot of what's been done in confidential computing by a lot of other parties, including some of the cloud vendors, has been really much more along the lines of what I'd call glorified proofs of concept. And part of the reason for this, and you and I have talked about this before, is if you want to, if you want to actually do something productive with confidential computing, you need to be able to orchestrate an application, and because you need to be able to get the application as well as the data workload into that confidential computing workspace, what we call an enclave or a trusted execution environment. And if you don't have an orchestration platform or a control plane, then all you're really doing is using APIs to stick a workload into essentially a glorified POC. And so this is actually what's been happening with a number of the cloud vendors out in the marketplace. It's not something that's been that where we've been involved in it, because we developed a control plane early on that we call Confidential Computing Manager. And Confidential Computing Manager actually integrates with our data security control plane, what we call Data Security Manager, so that we can encrypt the data at rest or tokenize it. We can move it securely. The TLS tunnel terminates inside the enclave, so we can move that data securely um, into a data plane, and then we can bring whatever kind of analytics or AI or some other type of some other type of application workload in, and we can get some productive work out of the data. But that kind of orchestration platform does not exist in the cloud platforms natively. You need to be able to do things like whitelist applications. You need to be able to make sure that attestation can check identities of users, machine identities, make sure that that all the version levels line up, make sure that no bad code's been injected into a model or bad data has been put inside of the enclave. And all of this happens with multiple levels of attestation that Intel helps to create the environment for, and we orchestrate with this control plane. But you have to have that control plane to actually run apps.
Right. So, and that's what I love about your guys' company and your product offering is you're making confidential computing easier to use, which there's a lot of benefits to it. But let's just delve into confidential because we can go on the whole time. Let's talk about the hot topic today, which is Gen AI.
Hmm.
And um, right now, there are so many. It's like the Wild West, and people forgot everything about security and data management. It's
Yeah,
just the complete Wild West out there. We've seen lots of attacks on Gen AIs already,
sure.
data leakage, all this stuff. And I'm a little bit concerned that we've kind of taken the security. Zero trust was the buzzword right before Gen AI came out,
Right.
and you can't even find zero trust is like nowhere anymore, right? There aren't
Right.
zero trust conferences. So
Oh,
so how do we help organizations wrangle in, which I think it's going to happen. We're going to get a Gen AI that gets hacked and starts doing things, and we're going to have a black swan event around Gen AI and security. I just already know it's going to happen. So
yeah,
how do I help, and what areas do I need to protect these models? Because you said you guys are all about data protection. Well, these models are just data. They're really just data,
that's
right?
right. Yeah. It's an interesting question, and maybe I can just take a step back before we talk specifically about Gen AI, because you and I have had this discussion before. We have a good bit of experience at protecting what I call algorithmic AI, right?
Yeah.
Which is AI that's designed to do a specific thing, right? An algorithm or a model that was built to do something like find a rare disease diagnosis, in young children, or
Yeah, we've done a lot of work with you guys on cancer research algorithms,
inventing a new
right?
molecule. That's right. All those kinds of things, or even something that we built together. Our companies built together for last year's public sector forum, and that was using a genetic optimizer model to pull information off of critical energy infrastructure, so that you could be able to see whether or not an adversary were trying to take control of one of these. In this particular case, wind turbines or some other type of critical infrastructure. So, I mean, as you know, we've securely trained models to help diagnose COVID from chest X-rays, where the images were converted inside of the enclaves, so that we could strip out the PHI and protect the identities of the users. Same thing with brain scans. We've taught models how to tell the difference between a fighter jet, a jet airliner, and a missile based on secure object detection. So, but all of these kinds of environments are, as I said, I call them algorithmic, or some people call it linear AI. In other words, it's something that's designed to do a thing, and it's not going to do a whole range of things. It's going to do a specific set of things. Now, we've had to protect this kind of a workflow before, and we do it with a combination of our control planes, right? By securing that data at rest, bringing it into the enclave, bringing the model in so it can transform, so it can train and then inference that particular problem and come up with a predictive result. And we're not AI guys, but what we've done is we've taken the foundational technology that Intel's developed, and we've built workflows that allow you to orchestrate that application all the way through from choosing the data, bringing the data in, encrypting it into the model, training, and then a predictive result. Well, so we've got several years of experience in doing this. We've probably built 20 different solutions along these lines.
So real quick before you get
Yeah.
into that anymore, why do I give me some of the reasons why I need to protect, why I would protect this in the enclave, in a secure enclave or trusted execution environment, and why not just say, well, it's in memory. It's so what? I'm encrypting it.
Yeah.
When I move it, I encrypt it at rest. But Why not just leave it in just normal memory? Because, I mean, come
Well,
on.
it's in well, okay. So this goes to the original discussion you and I had about zero trust, right?
Right.
So the way I like to explain this to people who are not familiar with confidential computing is that when your data is at rest, you're not doing anything with it, right? You need to move it someplace so you can transform it. So you're so it's when it's at rest and it's encrypted, it's pretty safe, at least until quantum computers come along. They can
Well, let's not talk quantum yet.
Yeah, we're not talking quantum yet. But in any case, it's pretty safe. When you're moving it through some type of a tunneling technology and it's inside that encrypted tunnel, like TLS, it's pretty safe, right?
Right.
What happens when it exits that tunnel at the destination server, and there is a destination server somewhere in the cloud, on premises, in a private cloud, there's a box or a blade that's got memory, CPU, and all the other
Right.
pieces.
Yeah. So
And
it's there. It's secure. It's
well,
secure in that OS.
it goes into the memory of that destination server. Well, it may be secure, but it may not be because you have to decrypt it now, and now it's in the clear, right? So it's running in the clear, and so what that means is if the bad guys can find that server, they can use a modern exploit to exfiltrate the data. They can use a man-in-the-middle attack or try to spoof the network into thinking that it arrived safely, right? They can use a memory scrape, literally a package you can download off the web,
I
and then
wrote one when I was in high school, a memory scraper.
it was you. It was,
Yeah, it was me. Yeah.
or they could put a rootkit in or use social engineering to gain access to root, and once that happens, you can then exploit that workload. So what has the industry done over the course of the last 15 years is introduced this whole concept of zero trust, which is not just least privilege access, it's also a defense in depth environment, right? It means you've got to have the latest and greatest networking security or perimeter security. You've got to have identity and access management. You've got to have endpoint, right? And so what that's led though is to the CISOs of the world allowing themselves to sleep a little bit better at night because they think they've done everything. But if the bad guys find their way across those defenses and they can find their way to that server, that data's in the clear along with that application. And if you're a biopharma and you spent $5 million inventing a
Oh,
new
really?
formula,
Yeah.
that could be exfiltrated as well. Your intellectual property could be gone as well as your data. So this is why protecting the data in use is so important because it's the last line of defense.
So this also prevents data corruption too, because not only is it data um, i- uh, capture, it's
Yes,
also I don't want anyone injecting anything corrupt into my data. So if I'm in a secure enclave,
that's right.
they they can't they can't bump into it. They can't
No,
change the data from the time that it's transported to the time it's in memory,
the way I
because
like to describe it, Darren, is that if you think about the server, right? The server's a layer cake of stuff, right? There's hardware, there's network, there's operating environment, there's virtualization layer. So it looks like a layer cake of stuff, and at the top is that memory, right? The application space, and the way I like to describe it is imagine that as a box that's encrypted on all six sides. And so you want to lift the top off the box. You want your data and your application to go into the box. And once you close the box, to an adversary, it looks like a solid cube of encrypted bits. Like they can't do anything with it. And the proof of this, again, as you and I have talked about many times, is that there's never been one bit of data that was being protected by confidential computing that's ever been lost, that's ever been breached in the wild, not one bit. And that's anecdotal evidence, but it's pretty powerful anecdotal evidence.
yeah.
So let's just assume that technology is pretty secure, right? So now you want to go back to the model that we've been talking about of I have AI or I have machine learning and I want it to transform this sensitive data, whatever it is, mission data or financial data or personal data or health data, whatever, I want it to transform this. I want to get a predictive result out of it. Well, now, because I'm using confidential computing, that data cannot leak from that memory. And because we've encrypted it at rest and encrypted it in motion, and because the tunnel terminates inside that enclave, now there's no place for the bad data to get injected. You have control of the data from at rest all the way through to in use. And all you're going to get out of it is an encrypted result, that you're going to get that predictive result in an encrypted report that's going to go back to whoever requested it.
So this is pretty cool because I can see a lot of applications for this, not only in inference like you just talked about, but also during training.
Yes.
Because if my data coming in to train my model is encrypted and the model itself is encrypted, that means no one can inject things in the memory space, that is one of the things we're starting to see now, people getting root access
Mm-hmm.
and injecting, bad bits into these models. Now I can guarantee that my model is clean because it was built in a clean room.
That's
It
right.
was built in the secure enclave,
Mm-hmm.
and I can protect the model because I truly believe that we're going to see a lot more small language models
Yeah.
that are going to become very powerful for very specific types of applications where people are going to pay money for these small language models, and they're going to pay a lot of money for them
Yep.
because of what they can do. So we want to make sure that those are protected and that no one can infiltrate or mess with those models at all,
That's
right?
right.
So this
Yeah.
is a good. I see it both for inference and also for training.
Yes.
Um, have you guys built any tools around AI and specifically around Gen AI and these secure enclaves, or is this easy for me to do with your tools? What do you guys have anything in this space?
Well, what we have built is something we call confidential data collaboration. And so that's a
Oh,
matter of
okay.
being able to bring different data sets in from different data sources, right? Who may not know each other at all. And you need to establish a trust relationship with them so that they know that their data will never mingle with anybody else's data in any unencrypted manner. So you're able to bring those into an enclave, and you're able to do differential security on them, or you can, they're used in environments like, for example, where it's used a lot in advertising and marketing, in fact, where you might have a very sensitive intellectual property around some kind of a campaign or some kind of it could be, information on a movie or these kinds of things. That data has to come in, and you want to run analytics on it, but you can't do it unless it's inside of that enclave, right, where the data will not leak, and all that comes out of it is the analysis of the data, not any data. So,
So
yeah,
that's really cool because now I can have multiple um, uh, different parties contribute to
yes,
and not and like if you and I were contributing to this AI on our healthcare, but you didn't want me to know anything about your health, and I don't want you knowing anything about my health, right? But we want the end results on how to treat, you know, guys our age, right, that are old and live in California. Um,
classics, classics.
Classics, yeah, classics, right? But this is a really cool way because we could both put our information in. We don't know what each other put in,
That's right.
and when we can both take advantage of this AI that we both built and
Yeah.
ask it questions, and you can't even see the questions that I'm asking because that's still all encrypted. There's no way for you to get that information out.
So, Darren, I have a very practical example of that, and an actual customer. It's a joint customer of yours and ours, obviously, but it's a company in Asia, and what they've done is they've built a data market for healthcare data. And so they have agreements with retail pharmacies, with pharmaceutical companies who are developing treatments and things like that, with healthcare providers like hospitals and doctor groups all throughout Southeast Asia. And the agreement is those people will contribute their data in an encrypted form. So the all
The
the
pharmaceutical
identities,
companies can't see it,
it's all
right?
stripped out. That's right. But all of that stuff goes into an enclave, and then analytics are run on that. And the result of that can be used with organizations that then have to go and try to build new molecules for treatment programs or whatever the case may be. So and they're able to monetize the analysis of the data, and they can only do this using this confidential data collaboration only because all the combination of the data is being done inside the enclave, and none of the PHI can ever leak.
See, that's super cool, right? So I can see so many different uses for this on protecting Gen AI,
Mhm.
protecting the data coming in, even the inference coming in,
That's right.
right?
Yeah.
Because I mean, we all know it's funny, right? You've heard about the Samsung data leak on OpenAI
Yeah.
on ChatGPT, right? Everyone's heard about
That's right.
where hey, the engineers, we like using new tools. We put our meeting notes in there and say, give me all the ARs from this meeting, all my action required, or from this meeting,
Hmm.
and hey, all that data is now in there, and someone got that data. It was that with this model, no one can see that data, which is pretty slick, right?
No, that's
Not
right.
even the ones running the model can see the data because it's
No,
in that secure enclave
that's the beauty of confidential computing, right? Is that it's really it's truly secure from
from
everybody.
everybody.
Let's see how we get from here to generative AI, because what we've been talking
Okay.
about so far are these more single purpose AI kinds of environments, right? Or very specific sorts of things. And I agree with you that we have not tapped out this small language models, we could call them, or maybe more algorithmic AI. That is still going to be the bulk of AI work that is done in the world for the foreseeable future. However, the buzz is around these large language models, these learning systems and generative systems that will take huge amounts of data, train on that data, sort of the data of the world, train on that. And now you can ask natural language questions. And the answers that come back can be anything from, a straightforward answer to a query to a full report or a study or something that a human analyst or a set of analysts might have had to work on in business intelligence or programming support or pure research or pattern matching. So these systems are extremely powerful. Their ability to learn faster than humans gives them this incredible capability. But because they're trained on such huge amounts of data, there's so much risk that the data could be poisoned, which would lead to what they call a hallucination in the AI world, right? You plain and
Right.
simple, it would give you a correct answer that would be the wrong. That would be it would be correct based on the model and the input data, but the answer to the question would be wrong. And it's
Right.
already been proven
Oh yeah,
that
we see that a lot. Yeah.
see it all the time, right? And you also see models that they'll lie to you, right? And
Oh
the
yeah.
reason isn't because there's a you know there's a bad guy behind it. The reason is because the models get trained to give you a response based on a reaction or response you want from the model. So they learn that if they give you something that's what they think you want or the model thinks you want, that you'll be happy, right? You'll be satisfied
Right.
with it.
Right.
Well, that may not be the actual answer to the question. So therefore, the what and this goes back to your issue of breaches, but also many companies banning the use of Chat GPT, for example, within the company perimeters because it's not controllable,
Right. Yeah. Yeah. It's not controllable. Yeah.
right? So our approach to this, Fortanix approach to this is it's going to need to be secured end to end. And that means from the data connector all the way through to the LLM and to the predictive response. So the model, if you think about it, generative AI, to get something productive out of it, it's a pipeline of things that have to take place
Right.
from all the way from that input of data all the way through, right? You need a bunch of different components to make it happen. You need a retrieval engine that will pull the data that's been prompted by the user in from your data sources. And data sources, could be internal company data. Things like
Right.
like your Salesforce.com, or in our case, we use HubSpot, but
Yeah,
different
it could be that, or it could be product manuals. It could be
SharePoint.
policy manuals. Yeah.
Exactly. People's their salary data, all these kinds of things, right? So you have to have a data connector. You also probably will need data connectors, secure data connectors to potentially cloud storage like Snowflake or Databricks or whatever the case may be. Okay, so you've got a retrieval engine that's got to come in. Now you have to embed that data in a vector database. So you're going to have to chunk that data. It's going to, the
Yeah, you're
vector
talking
database.
about a RAG implementation, right?
It's exactly so. Yep.
So I need to protect my RAG as well. So here's a good question because I'm not going to run all of these things on one server. I'm
No.
going to run them on multiple servers.
Yes,
So, but confidential computing only runs on an individual machine, right?
that's right. So
So
what
how
you're going to
do
have
I
to
mean?
do?
I've got these secure enclaves running on each server
Mhm.
that, but these things need to talk to each other. They need to share information back and forth.
Yeah, they
And
do.
how am I guaranteed that who's sharing information with me is someone I trust?
Yeah, it is. That is really the question. The question is, the data that's coming in is that data. Does that data have a provenance that you can trust? The other thing is, the users. Are they the users that can be trusted, and how do you know that, right? And so so I'll tell you what our approach is to this, right? And that
Yeah.
is,
Yeah.
the retrieval engine is going to need to be in an enclave. The embedding model is going to need to be in an enclave. The vector database is going to need to be in an
Oh,
enclave,
absolutely.
and the,
That's the jewels right there, the vector database.
and the LLM is going to need to be in an enclave. Now, think about that, right? So, can you use a CPU enclave for some of this? Sure, you
Oh
can.
yeah.
Sure, you
Yeah.
can. But when it gets to the LLM, you might need GPU. In fact, you likely will, right?
Yeah, yeah, we don't want to talk about that, but you're right.
Well,
You do need a GPU or an NPU, right? Coming in
yeah,
the future, right?
you need
NPUs.
that's right. You need multiple cores. You need a lot of memory. You need enough space so that the transformation can take place, right? The other thing that you're going to need is at the prompt. The prompt engine is going to need to be incorporated with confidential computing. So, and that's where all your role-based access controls or your policy-based access controls are going to go. And what happens is you're going to need to make sure that the workflow is such that when it gets to the embedding model, that those role-based access controls marry up so that, let's say somebody wanted to prompt your system. Oh no, Mr. User A, you don't have the right to make that prompt, right? And so those things need to get filtered out. So now there's a whole concept between these processes of what we call AI guardrails. And this is something that we're developing actually right now. And those guardrails will at every part, like think of them like connective tissue between those processes. What'll happen is those guardrails will perform DLP, redaction, checking credentials. So at every level, so not just at the beginning, but all the way through the
All the
process.
way through.
Right.
Oh, that's cool.
Yeah. So that's how you secure the pipeline, right? It has to be from all the way at the front edge, provenance of the data, to the users, the credentials, and make sure that data leakage can't take place anywhere along that. That's how you do the best you can to make sure that you're not injecting anything into that model that might create a hallucination like we talked about, or bias, right? Which is another thing that's
Right, right. So this is really fascinating. I really like the approach. I like that that it's distributed,
Mhm.
and we can establish trust between the enclaves.
Yes.
And I love the AI guardrail concept because now I can really kind of tighten down the security of my Gen AI. Patrick, if people want to find out more, they just go to Fortanix.com. Do you guys have any white papers or anything on this that they can find out more information on how to secure their Gen AI?
We haven't announced anything yet, although this isn't what I'm talking about is in development. So what I would say to all of your listeners and viewers here would be to contact me. Contact me at patrick.conte@fortanix.com. And if you want a briefing or you want to set something up, then we'll be happy to set that up with you. We'll do it, we'll do it on a one-to-one basis. We're not ready to do this as a, for example,
You don't just download it and run, right?
Exactly. Yeah. We're not there yet. And plus, we need to make sure that all of these piece parts are in place so that we can secure the entire pipeline. But this is what we're building, and this is our approach to it. And we will be actually accepting early access program candidates in the very near future, within the next month or 2 months at the very most. So this is happening now, right?
That's very cool. So bleeding edge stuff. Bleeding edge
stuff hasn't been announced. I haven't announced it to anybody. I've just said, here's what we're, here's
nothing
our.
Yeah. No, I love the recipe. I love the concept. Thanks, Patrick, again for coming on the show. I always learn something new when I talk to you, and it's always good to see you.
Thanks. Great to see you too. And I'm sure we'll do this again sometime. At least I hope you'll invite me back sometime.
Oh, well, of course. Yeah. You're a great guest. So thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.